All right, Ben. It's your guess again.
I feel like this frog should be remixed into some sort of, dubstep-esque.
Yeah, it is a bit of a dubstep
Right.
sort of sound, isn't it? Yeah.
Oh.
Yeah. This one was sent to us actually. This is not my doing.
Ah, so it's not connected to the paper we're about to speak about then. That would be
I don't want to say no prematurely.
an outrageous coincidence.
No. It's nothing to do. It's from a different place. That's a big clue because that rules out Australia. So
oh my gosh.
we're going to talk about Australian species later. Spoiler alert.
It's sounding like a ground dwelling frog, something that's crawled out of the mud, I reckon.
Little muck dweller.
Yeah. That isn't Australian. I would put money on it being sort of Central American.
Hello. Okay. Getting warmer, Ben, much like the frogs in our episode.
Okay, so northern Mexico.
South. Go south.
Costa Rica.
Hey-oh. Costa Rica.
I don't know many Costa Rican frogs. And by many, I mean any.
Here's a good clue for you, okay? And if you get it, you can still have it. But it's... You'll never get this. It's got something to do with a very popular 90s TV show. And I'm not going to tell you any of the names of the characters because you'll get it straight away.
The
In the UK, it was popular. I don't think America knows about this program.
horseshoe toad.
And what program has that got anything to do with?
I don't know.
Only Fools and Horses.
Only Fools and Horses.
Wasn't that before the 90s as well?
I have no idea.
I'm sure that's from like the 70s.
No
Anyway,
idea, mate. No idea.
No. So the TV show I was referencing was Gladiator. Do you remember that?
Oh.
Contestants,
Okay.
you will go on my first whistle. Right, let's stop that. And the reason being is that is the sound of a gladiator frog.
Gladiator frog. So they fight, do they?
They battle. Lethal fights between males as well as...
Lethal?
Yeah, they fight to the death.
Oh my days.
Yeah, so it was the call of A, Hypsiboas rosenbergi, aka Rosenberg's gladiator tree frog, and this was sent to us
Oh, so
by
they're in
Jesse.
trees too. They're not even ground dwelling like I
They're not even
suggested.
really muck dwellers.
It's complete
no.
nonsense.
Well, you tried. But yeah, so this was sent to us by Jesse Yates, who's a PhD student at the Department of Biology and friend of the podcast. At University of Central Florida, I should say. That's where the Department of Biology is. And Jesse said, "Hey, y'all, in honor of me studying my isthmus herps to prep for a trip down to Panama next week, you lucky duck, I thought I'd send along a frog call for y'all. It's a Rosenberg's," I can't say y'all, by the way, I don't really know how. "It's Rosenberg's gladiator tree frog, Hypsiboas rosenbergi. They're fairly common around natural areas like Soberania National Park, but data indicate populations are decreasing. I'm also attaching a spicy frog pic of the species from my trip last summer. Loved the show, keep it up." And the frog pic is a bit spicy, Ben. I'll put it in the Discord so you can also enjoy it, and I will press send this time. Oh, it's one of those weird formats from an Apple phone, so maybe you can't see it.
Don't worry. I got this.
You got a fan view, mate. So yeah, yes, it's quite a chunky little frog with a really weird sort of upturned pointy snout. As I said, the males battle each other, and the males will also clutch guard, so they'll
They're weirdly flat. Why are they so flat?
Don't know, yeah. And obviously they're mating in the picture I sent you. That's what makes it so saucy.
Yeah.
It's two frogs in amplexus, sort of sitting on a low hedge, sort of looking a bit blinded by light as well. It's quite funny. But yeah, so they fight and they lay floating eggs and the males guard them. That's kind of all the amphibia web has.
I can't get over the fact that they'll fight to the death. Like that strikes me as quite unusual.
Yeah.
Like we've talked about sort of what's termed ritualized combat quite a few times, but to the death it's pretty extreme.
Yeah, it's also quite uncommon, really, isn't it? Like most herpetofauna tend to do more ritualized combat, which kind
Yeah.
of doesn't generally end in savage death.
Right, this is
even
what I'm
bad
sort
injury.
of makes me wonder what drives a species towards one and not the other.
I really don't know.
Yeah.
But yeah, they're brutal. But yeah, thank you very much for sending
Superb call too.
that one in
was
to
fun.
us, Jesse.
I like that one.
Yeah. Please keep the calls coming. It's so nice. It just saves me a job really. You have to look it up. Just someone sends them. So let's move on, shall we? We're carrying on. We got frogs. We got Frog Day today, and
time.
We're moving on from frogs that fight to frogs which are locked in combat with a terrible, terrible fungus. Ben approves of the segue, but only a little bit. So this one was by Waddle, Clulow, Aquilina, Sauer, Kaiser, Miller, Flegg, Campbell, Gallagher, Dimovski, Lambreghts, Berger, Skerratt and Shine, 2024. Hotspot shelters stimulate frog resistance to chytridiomycosis, published in Nature. So, we've talked about chytrid quite a lot, haven't we, Ben, on the podcast? Chytridiomycosis.
Yep.
That is the name of it's an infectious fungal disease which has been ravaging frogs globally. It is thought to have originated in Korea.
Yes, and then potentially transported around about the place via Xenopus, right?
Yes.
Wasn't that one of the ones sort of, what's the word? Implicated.
Yeah.
In its spread. Xenopus being moved around for all sorts of numbers of reasons, but human propagated, human moved, not Xenopus itself swimming across oceans.
Yeah, the African clawed frog Xenopus, they didn't mean it. It just happened. They just happened to be, I mean, we talked about them on the podcast before. They're the frogs which just made themselves way too useful to humans. We used to use them as a pregnancy test kit. Because what is it? Something happens to them. Do they ovulate? They produce eggs? I can't remember what it is, but if you wee on one when you're pregnant, something happens. And you can tell. This is a fungus, chytridiomycosis. That is the name of the fungal disease. And the frogs in Korea, where it comes from, can probably live alongside it, but it's been subsequently transported all over the world by human transport. And obviously the pet trade has played a role as well. Now it can be found in Western North America, Central America, South America, Eastern Australia, East Africa, Dominica, Montserrat, the Caribbean, and it's caused the extinction of at least 90 frog species. So this is a serious threat to frogs. We've known about it since the sort of 70s. And this is different to the one, there's a kind of a frog one and a salamander one. They're both, Atrachochytridium is the genus of the two fungus. The one for salamanders is Salamander vorans, and the one for frogs is Dendrobatidis. But yeah, it's a fungal disease. We call it chytrid, but it may have an Achilles heel. So obviously it's ravaged frogs, caused 90 extinctions, loads of declines. But it might have an Achilles heel in that it is known that the fungus quite likes low temperatures, at least like low temperatures relative to the tropics where it's found.
Yeah.
And outbreaks tend to be in Australia. Outbreaks tend to be in the winter and early spring, and these periods of fungus success where it's cold tend to kill lots of frogs. So in Australia, they see really big die-offs of frogs in the spring and winter because it's the cooler temperatures which are better for the fungus. But it's known that in the lab, temperatures over 30 degrees centigrade will kill the frog. Kill the frog, kill the fungus. The frog's fine. The frogs
are tougher than that, yeah.
Yeah, the frogs can survive 30 degrees, but 30 degrees will kill fungus in the lab. And similarly, increased temperature, even for just 4 hours a day at 29 degrees, can significantly reduce the infection burden.
Yeah, this sort of pulse of heat destroying the fungus and then leaving this frog unscathed, hopefully.
Unscathed. So the authors of this study, they were armed with this crucial piece of knowledge that the fungus does not tolerate high temperatures well. Then they needed to pick a frog to experiment with. So they chose the green and golden bell frog, which is Latoria aurea. What a beautiful name. And yeah, as the name suggests, they are green and gold. And despite being in the family Hylidae, which is kind of generally considered to be tree and leaf frogs, they're generally quite terrestrial in their habits. But ultimately, due to chytrid, as well as introduced fish species, habitat loss, habitat alteration, all the normal stuff, they've disappeared, unfortunately, from over 90% of their former range. So massive, massive declines of this species, the green and golden bell frog. But because they bask to warm up, and shelter in cool areas during winter, they're known to tolerate a wide variety of temperatures, which makes them perfect.
They love a bit of basking, these frogs.
They do.
Yeah.
They are. They're thermophilic. They like the heat. They'll seek it out. But yeah, chytrid is well documented in this species, and it has actually even been implicated in hampering reintroduction efforts. So there was a reintroduction to the Hunter region in New South Wales in Australia, and in this reintroduction they released 850 tadpoles, which had been reared in captivity, into a closed system of 3 ponds and rehabilitated habitats. So it's supposed to be like perfect for the species. And many of the tadpoles survived. Tadpole survival was really high, but after they metamorphosed into little frogs, a massive decline in numbers began that continued for 13 months and resulted in the disappearance of all the released bell frogs. So they pretty much all died. And the cause of this decline was investigated and eventually found to be due to chytridiomycosis. They'd been infected by the chytrid fungus. So this species has a history with the fungus. It's currently being ravaged by the fungus. And we know that warm temperatures kill the fungus. So these authors basically tried a bunch of stuff to try and work out how temperature and chytrid interacts and how they can and like kind of what happens when they subject frogs with chytrid to varying temperatures. They had a kind of a suite of experiments which we will get into. So I think we just start at the beginning, Ben, with the temperature gradients.
Yeah, I think so. I think we just follow the flow of the paper because it flows quite nicely. And
yeah,
so first off, get a bunch of frogs, put them in different sort of control environments, and see how different temperatures, different sort of temperature scenarios impact the infection intensity of this fungus on those frogs. So we had a low temperature control that was something, what was it? 19 degrees, I think it was. And then you had these 2 higher temperatures ones. One that had all the frogs were contained in this area that was all the same temperature that was their sort of ideal or selected for, which I think was about 31, 29?
Yeah, it was
29.
between 20. It was between. Oh, was this the one they chose that they stuck them in?
Yeah. Well, you had one was uniform temperature that was quite high, which was 29, I think.
Yeah,
and then you had a gradiated one.
Which
so the frogs could sort of move from higher temperature areas to lower temperature areas as they deemed fit.
Yeah, and they also had the ones which were just kept hot.
Yes, so you've got kept cold, quote unquote,
kept cool,
kept hot, and then allowed to move across a gradient.
Precisely.
And then you compare the intensity of infection between those 3 groups.
Yeah, so they gave them 2 weeks, didn't they? They sprayed them with chytrid, gave them 2 weeks to develop a serious amount of fungal infection, and then they put them in these different conditions. And it was like really, really striking, actually.
Massively striking, yeah.
Yeah, not surprisingly, the group that were kept at 19 degrees, the cool group, they maintained very high levels of infection of chytrid because the fungus loves it. However, the frogs that were kept at their kind of preferred warm temperature had much lower infection rates, with most of them clearing the infection within 2 weeks after the sort of study started. But what is even more hopeful is that the frogs which were allowed to choose their temperature within a thermal gradient all cleared the infection after 2 weeks in the gradient. And so they were kind of selecting hot temperatures themselves, and that actually cleared their infection. Which is great. I mean, it's a super hopeful thing. Like you all you need to do is put these frogs in some warm temperatures, and they seem to be able to get rid of chytrid. So they'd established that. They moved on. They wanted to see whether the frogs could get a resistance to the fungus after being exposed, and so they gave a bunch of frogs the fungus again. Heat treated them at 32 degrees for 2 weeks to completely clear the infection, and then reinfected them.
So the idea is these frogs have had the fungus, whatever immune response has been sort of prompted, but then they've been cured by the heat. So they're ready to go.
Yeah, but they've experienced the fungus, and they have then developed, hopefully, some kind of innate resistance to it, some way of fighting it within their own bodies, or on their bodies, because it affects the skin. And this was also very, very striking. So they had one group which had been previously infected, and one group which had not been previously infected. And the ones which were previously infected and recovered were 23 times more likely to survive the second exposure compared with the control frogs, which had just been heat treated but hadn't had the infection. So if they'd been infected before, 86% survived. If they'd never been infected before, only 22% survived. And I mean, 22%, like if you're losing 78% of your population, that ain't no good.
I mean, it depends on the sort of reproductive history of the animal, doesn't it?
To some extent, but I mean, if you just take it at face value, if you said
face value, it sounds pretty bad, especially when the comparison is what do you say, 80%?
You're right, Ben, because we should never speak in absolutes, should we?
Only a Sith deals in absolutes.
I mean, there you have it.
So, many species will experience large dramatic declines and then recover. But yeah, if you got a fungus coming in and killing 76 or killing 78%, it's probably pretty bad. So they then had discovered that the frogs themselves kind of built this resistance after they'd been infected before. And once they'd done that, they kind of moved on to the really cool bit, at least I think it's cool, which is what makes this paper so groundbreaking. And they created what they call mesocosms. So these are essentially big outdoor, well, they're not that big, they're like outdoor kind of enclosures, like a big...
It's a sort of semi-wild environment, right? Where you're getting the natural conditions from the outside world with the sort of control that you'd want from laboratory conditions, but combined together, right? Like, it's a nice middle ground.
Yeah, and these are like these big, massive, sort of like giant plastic paddling pools, really, but I think they're quite solid. And they had, inside them, they had like water and gravel. So there's like gravel built up over half of it and the other half's water. So it's kind of this like land-water interface. And then they had like some plants, some plastic plants, some pots to shelter in, which was all nice and symmetrically laid out. But then they also had this stack of bricks, these black bricks, which they put in the middle of the thing, and they covered it with a greenhouse. And the idea was that this would be this sort of like artificially hot zone, because in the Australian sun, black bricks covered in a green sort of tarp, greenhouse type thing, will get very hot, at least much warmer than the surrounding environment. And
the frogs like to shelter in the bricks. That's the frogs. That's the critical bit of information here. It's their sort of place to chill out, and two different setups with that shelter site.
Yeah, there was one which was more shaded and one which wasn't shaded. And the one which was shaded was like marginally cooler than the one that was shaded. And so, what they found...
3 degrees difference, I think, was what they were saying, yeah?
Yeah, but crucially, they had access to this hot area of refuge if they so chose to go in it. And as it turns out, the frogs selected the hot greenhouse cover bricks. They went in there and it actually reduced their infection burdens. And they think this is because the frogs are thermophilic. They just like it hot. Like they're not consciously trying to rid themselves of the fungus. And they think that because they didn't find evidence of what they call behavioral fever, which is like seeking out hot temperatures to try and cure yourself. In other studies, it seems to be that these hiding places are just nice places for them to go, and they're hot, so they choose to go there because it's hot.
So they're choosing them because they're nice places to hide, as opposed to
fix themselves of the fungus.
But in this case, they are choosing them because they're hotter. Yes.
They like it hot, basically, and it just so happens that when they go somewhere hot, it cures them of the fungus. So it's like it's a win-win, basically. Frogs can kind of behaviorally thermoregulate, reduce their fungus burdens. You mentioned, Ben, that there was shaded and unshaded. Essentially, the difference between those two treatments was that the ones in the unshaded, so where it was hottest, were cured of their burdens of fungus more quickly and more effectively compared to the slightly shaded one. So basically, a little bit hotter equals a little bit better. So the frogs are kind of their own accord going into these places, finding places that are hot, reducing their burden. And that's great. That's actually amazing, because this is an endangered species which can sort of help itself rid itself of this fungus.
Yeah, sorry, I'm just rolling back to the behavioural fever aspect. The reason that they don't find evidence for it here is that the non-infected frogs will seek out these hotter areas. So it's not that's the bit that allows you to separate these two things that I was missing. So regardless of infection status, they prefer heat, as opposed to, I'm infected, I better find somewhere hotter, what has been seen in other species, where only the ones that are infected will seek out these hotter areas as a means to combat whatever infection that they're going through.
Has that been shown in other species, that they choose it only if they're infected?
That's what they're they're suggesting that southern toads and Panamanian golden frogs, there's a couple of papers cited there that suggest behavioral fever. But I don't know, I haven't read those papers specifically, so I don't know if it was only the infected ones that would seek out these areas, because I'm not sure if they had any uninfected individuals, potentially.
Yeah, that was what I was curious about. I like behavioral fever, though, don't you? I think that's a cool term.
So the sentence for the field research on Panamanian golden frogs reported increased body temperatures after the arrival of BD in the environment, suggesting behavioral fever.
Yeah, but that could also be suggesting the ones that didn't like it are dead.
Potentially.
Yeah.
I don't know. I haven't read the papers. I don't want to over egg the existence of behavioral fever, but they obviously it's an ongoing discussion. Otherwise, they wouldn't have brought it up in the discussion themselves. This green and gold bell frog doesn't seem to be the case. It just seems to be that their naturally thermophilic tendencies have this additional benefit of burning off the fungal infection.
Yep. And yeah, that's supported by another study on the closely related Litoria spenceri, which found that daily fluctuations improved disease outcomes. So that was one where they gave them the pulse of the hot temperatures, I think.
Right.
That helped the disease. And also another example that they cite, which is from the wild, is armored mist frogs. So that's Litoria lorica. They persist in sites where there are large boulders which absorb heat from the sun all day and provide kind of these warm nighttime basking sites. Whereas populations in more dense forests nearby have gone locally extinct because of this fungus. So
see that it's little bits like that are so fascinating to me, because that's not just a species vulnerability to this infection. It's species in a given environment is more or less vulnerable, and potentially individuals that have different preferences there may be more or less vulnerable, right? Ones that love a bit of basking on a boulder, they're going to be doing better. So you can see these sort of potential for quite strong selection for certain behaviors or certain traits popping out of differences in habitat or differences in behavior here, because I'm assuming with that species that the fungal infection probably has quite high rates of mortality if it's drastically affected the ones in the forest there. There's no way these frogs, the ones that survive, will be the same in terms of behavior and sort of potentially even habitat preference and stuff after this exposure, right? There's going to be some legacy here. And it's sort of fascinating in a sort of very grim way to see it happening in potentially real time. Yeah.
Yeah, it is cool. And so I think the cool thing, which the sort of main takeaway for me, at least, of this is that these kind of like artificial brick shelters in some form or another could be put in habitats where there are frogs and allow them to find it themselves, heat themselves up. Other thermophilic species which are seeking heat, it could really help them. Certainly in terms of reducing those winter die-offs, which are apparently like the time when chytrid gets you. Heating up animals which are supposed to cool down over winter kind of comes with its own risks.
But you're forgetting a critical aspect is if you can just get them to survive one infection, it improves their chances for the next one, right? They have a term in the discussion, this self-propagating resistance engines. So it's a one-time intervention that's sort of quite hands-off, even if it sort of doesn't work all the time for the wintering, because they do need to cool down in the winter. And, it's not like they're heated. It's just they're taking the sun's energy and sort of concentrating it. So they will cool down. It might just give them that buffer with that initial survival to give them more resistance into the future, right?
Yeah. I guess the only drawback I could see possibly would be if you wholesale put these black bricks out. All the frogs are loving it. They're getting rid of their infections. But then what happens if chytrid's still there and still persistent, but then you stop that intervention down the road? I don't know, all the bricks like eventually become rubbish and corroded, and just you've then got a cohort of frogs which have only got an immunity because they've had access to this thing. It's not going to be translated to their offspring because it's like a behavioral mechanism, not a genetic one. So it's like you're going to have to keep those bricks in the habitat forever, right?
Yes, possibly. Yeah.
Not to say you can't, but just something to consider. And they do
Well,
say,
the other slight thing is you need to put enough of them out so you're not creating like little hotspots of congregation of frogs and sort of propagating the spread. But I don't know how BD sort of spreads in these environments, whether it is more frog to frog contact or whether it's something environmental.
Yeah, and I mean, the authors themselves are very, very keen to point out this isn't a silver bullet. We do not have here a panacea for chytrid, but putting these things out in the wild could be easily done. It could be a very effective, quick, cheap conservation measure, which are effective, quick, and cheap. I mean, as far as conservation measures go, that's the three things you really, really want and need. And this is like undeniably a source of optimism, right? So often you read papers about chytrid. It's like, oh yeah, it's in the air as well. Oh, they can get it through this, they can get it through that, or whatever it might
soil.
be.
It's in the food they eat. Yeah,
it's in the spittle. Yeah, like. I don't know that it's in the spittle, but there was that one about it being in the water vapor, wasn't there? So, yeah, it's just nice to read something which is like, you've got a species here which is itself really seriously endangered, and there's these things which work for it. So fingers crossed they can get these things out and start helping animals. I'd love to see a paper in 5 years about like local recovery of a species because of these interventions.
I mean, I say watch this space, because if they're actively reintroducing them, and they had a case of, you were describing the tadpole success and then subsequent mortality, those sorts of scenarios, this could be perfect for, right? That little jump start as young frogs to get them a little bit resistant. And maybe you don't actually need these sorts of interventions everywhere, just maybe you center them round where they're breeding. And then dispersal and whatever can carry on. As long as you've got that buffer, as long as you've got something to sort of support a population that won't crash into non-existence, it might be enough.
And they had some really nice pictures in this paper of like the green and gold bell frogs just tucked in these little bricks and these little holes.
They're so really cute. Yeah. Squeezed in there.
Cool. All right. Well, there we go. So some optimistic news from the world of chytrid and
Super
Australia.
Yeah.
Yeah. Have you got any other business for this week, Ben?
I do not for this week, no.
No, me neither. So, if you want to get in touch with us, if you've got a question, if you've got a comment, if you want to correct us on something, you can get in touch with us, herphighlights@gmail.com. We're on social media too, if you want to find us as individuals. And I think all that remains to be said is thank you for listening.
Thanks for listening.